Outbreak. It's written by Robin.
Oh, I've read that. Was growth hormone in that?
Maybe not Outbreak. It might have been the second one. The
There's been a second one?
Mortal Fear. There's there's a series of 3.
Cool.
Mortal Fear talks about how a scientist manipulated growth hormone, so it was the death hormone. It was the opposite effect of growth hormone. It's a nonfiction, or it's a fiction.
I was getting ready to say, okay,
Yeah, it's definitely not
Are
true.
people starting to use it to stay younger?
Yes.
Now, yes, Meg, they are. You actually need growth hormone 24/7, 365, 366 if it's a leap year. It doesn't stop production. It is a hormone that targets all the tissues of the body and helps with their overall metabolism. We think of growth hormone because until we knew all the full effects, we did associate it with how tall a person got. Okay? Tall, short, dwarf, so forth. Now, growth hormone, look at what it can do. Stimulate uptake of amino acids. What do we need amino acids for?
Protein synthesis.
Protein synthesis. What is the only thing a cell can make?
Protein.
So therefore, protein synthesis. Does your body only do that at a certain time? Or do we make proteins all the time?
All the time.
All the time. 24/7, 365, say it with me. 366 if it's a leap year. Stimulate breakdown of fats to be used as an energy source. Stop it right there. Breakdown of fats to be used as an energy source. Does that only occur at a certain time? Or can that occur pretty often? It does occur. It can occur. It will occur pretty often. But it stimulates synthesis of glycogen. How do we store? In the form of glycogen, because that's our glucose that we're going to store for the short term in the muscle cells or the liver in the form of glycogen, because what is it that we need to do between meals? Well, we're going to digest our food, but we need which molecule? In other words, if I go from breakfast to lunch, okay, in between, do I still need to be supplying my body with glucoses?
Oh, yeah.
So, if I have temporarily stored them in the muscle cells or the liver cells, can they not be pulled out at that time, converted, made into glucose, and used by my cells? Now, which part of my body needs the glucose the most? My brain. So, stimulates synthesis of glycogen so that we can store glucose. Yes, no, maybe? Promotes bone and cartilage growth. We know cartilage grows, right? But at some point it does stop, correct? Because then we end up with cartilage, and cartilage doesn't repair, right? For the most part. But what about bone? Is bone something that was only built up one time?
No.
Bone is constantly being remodeled. So if it's constantly being remodeled, do we not need growth hormone all the time? Yes, we do. Regulates blood levels of nutrients after a meal and during periods of fasting. Do we only do that at a certain time? So what I'm trying to do is kind of break you out of that mold of your thought about growth hormone. Because a lot of times when people hear growth hormone, they simply associate it to how tall or short someone is. But growth hormone we actually need all the time, okay? Because there's not a tissue that it doesn't target.
For that last one, is it talking about insulin? Like,
No,
what does
this
it
is
mean by
talking
growth
about
hormone?
helping with digestion. And then, remember how like during the day, breakfast, lunch, dinner, usually how people think of meals throughout the day. But then we have that dinner and we have a long time before we go back to breakfast again. And the body has to maintain through that time period. And it's helping function during that time period. Because the one thing the body wants to do, provide glucose to the brain. And everything growth hormone does stimulates that. Either helping with, okay, we got glucose there, or if we got some, maybe put it into the liver or the muscle cells, or time to let it go and turn it into glucoses. Yes, no, maybe? So growth hormone, it's pretty important, I think, anyway. But that's just me, okay? So how do we regulate it? The way that we're going to regulate growth hormone. Now, we are in our anterior pituitary. Look at what will happen. We'll find that information can be picked up about the glucose levels. That information is going to make its way to the areas of the brain, going to pass the information to the hypothalamus. The hypothalamus, it can either deal with growth hormone, releasing hormone, or growth hormone inhibiting hormone. So basically, it can either stimulate or not the production of growth hormone. So, if we need to make the growth hormone, we're going to get this one from the hypothalamus. It's going to go to the tissue. We're going to produce growth hormone. Growth hormone is going to go to its target tissues. If it goes to its target tissues, we'll begin to increase all the information, such as the glucose levels. And if we can increase it, we need to stop it. And so therefore, the information going to the hypothalamus says, hey, we're good, stop the production of the growth hormone, and it'll stop the production, and then all of this will change, and glucose levels will be affected, and we'll need to go back to this one. We'll need the growth hormone. It'll say, okay, stop it, but then it'll say, okay, wait a minute, start it. We start, get my drift? Negative feedback is how we're going to control it. Now, when we stimulate growth hormone, it is going to help regulate growth. It's going to help tissue maintenance, because one of the things that it's very good with is the metabolism of the cells, of the tissues. So, if we can get growth hormone releasing hormone from that hypothalamus, it's going to cause growth hormone to come from the anterior pituitary and that's going to make the growth hormone go to the target tissues. The growth hormone binds to the receptors on the cells of the target tissue. If it binds to the receptor on that cell, it will make the cell have changes. A good example are the receptors on adipose tissue. If growth hormone can attach to the adipose cell, what will the adipose cell release? The only thing it can store is fat, so it will release it. The body can convert it to the glucose that it needs. Now, indirectly, meaning it's not going to go and have that cell do a specific job, but indirectly, it can cause the liver and the skeletal muscle to produce something called somatomedins. Soma means body. Okay? So the body's cells, all right? These are going to be insulin-like. When that gets produced, that insulin-like material will move to the receptors on the membranes of target cells. The target cells of this insulin-like product: cartilage, bone, muscle, affecting the growth. So, stimulation of growth hormone, yes, need it for growth, but you need it for growth all the time. What if we need to inhibit growth hormone?